Let's see template number 5. In template number 5, you have an objects. Objects may not be different. Okay. So in previous 4 problems, we have seen that objects are different. But here that n objects may not be different. Okay. So duplicates are allowed. Now in such n objects, where a1 type of objects are repeated t1 times and a2 is repeated t2 and ak is repeated tk times. Okay. In such scenario, how many different ways you can arrange them in the line? So all such objects can be arranged in n factorial by t1 factorial into t2 factorial into so on tk factorial. How? We will see that. So I take 3 objects a comma b comma c and I take n value 10. That means there are 10 objects and a kind of object is repeated 3 times, b kind of object let's say repeated 2 times and c kind of object is repeated 5 times. So I am taking these numbers randomly. Okay. Now how many different ways you can arrange them in the line? For that, usually what I do, I take positions, isn't it? Let me take suitable positions. We need 10 positions because there are 10 objects. Now, how you arrange these A's and B's and C's in this line? I can do systematically, correct? That systematical way is arrange A's followed by arrange B's followed by arrange C's. So arranging A's is nothing but first of all we have to see the number of A's. We have 3 A's, then we need 3 positions here, isn't it? Let me take 3 positions from these 10 positions first. How many different ways I can select 3 positions out of 10? So it's a selection problem, isn't it? Then that can be done in 10C3 ways. Like any 3. If you want to take any 3, it's 10C3. Remember it. Example, this is one of the any 3. Right, like 1 comma 3 comma 4. Once you select it, what are you going to do? You are going to write a, correct? You are going to fix A's. But you can do that in only one way, right? Once you select the positions, there is only one way of writing A's. So finally, the job of doing TA can be done only in 10C3 ways. Only here selection matters, but after that arrangements can be done only in one way. If you understand that, then I can explain you TB. So what is TB is arranging B's in the line after arranging A's. Since A's are 3, then 3 positions are gone, then remaining positions are 7. In 7 positions we have to now select 2 positions. So TB can be done in 7C2 ways and TA can be done in 10C3 ways. Now come to TC. What is TC? So arranging 5 objects in the remaining positions. Since the remaining positions are 5 and we have 5 objects, then 5C5 ways we can select 5 positions. After that arrangement can be done in only one way. Then these are the ways of doing TA, TB, TC. Once you know these values, and we know that already these tasks are independent, wherever you keep A's in the remaining 7 positions, we can select 2 positions always in 7C2 ways. That's why I say that all these tasks are independent. Whenever tasks are independent, we can apply the product rule. According to product rule, answer is 10C3 into 7C2 into 5C5, isn't it? Let's extend this idea to a bigger problem. What is bigger problem? You have n objects and a1 is repeated t1 times and a2 is repeated t2 times, so on, isn't it? For that our model is n objects, a1 is repeated t1 times, a2 is repeated t2 times, so on, ak is repeated tk times. Then first select positions for object number 1. Then it will be n c t1. Since overall positions are n, out of them you select t1 positions. After that remaining positions are n minus t1, isn't it? Because t1 are gone. Then from that you have to select positions for a2 which are nothing but t2. Then it will become n minus t1 c t2. Then if I extend it for third time, it will become n minus t1 minus t2, which are remaining positions. Out of them select positions for a3, which is nothing but repeated t3 times. That's why we have to take t3 positions for that. If you extend it, that will become n minus t1. This is for selecting positions for first object. This is for selecting positions for second object. This is for third object. By observing the pattern, you can say that for third object you have to write n minus t1 minus t2. For selecting the kth object, it will be n minus t1 minus t2, so on, tk minus 1, C, the last object tk. Let's simplify it. Then you get nct1 is nothing but n factorial by n minus t1 factorial into t1 factorial, isn't it? Then into n minus t1 ct2 is nothing but n minus t1 factorial by n minus t1 minus t2 factorial into t2 factorial, into n minus t1 minus t2 ct3 is nothing but n minus t1 minus t2 factorial by n minus t1 minus t2 minus t3 factorial into t3 factorial. So on, the last term will be n minus t1 minus t2 so on tk minus 1 factorial by n minus t1 minus t2 minus t3 so on tk factorial into tk factorial. So if you simplify it, what happens? N minus t1 factorial and n minus t1 factorial will be cancelled, and n minus t1 minus t2 factorial here and here will be cancelled. Similarly, n minus t1 minus t2 minus t3 factorial is cancelled with the next terms denominator. Then similarly, this n minus t1 minus t2 so on tk minus 1 factor is cancelled by this precedent denominator. Now the remaining terms, if you see, you end with n factorial by t1 factorial into t2 factorial so on tk factorial. Apart from that, you see one more term, this one, n minus t1 minus t2 minus t3 so on tk factorial. So we know that t1 plus t2 plus t3 so on tk is nothing but total number of objects, isn't it? You see here, in overall n objects, a1 is repeated t1 times, a2 repeated t2 times, and so on ak repeated tk times. Then all the objects are finally t1 plus t2 plus so on tk, which is nothing but n. So I can substitute that here. Then t1 plus t2 plus so on tk will be n. Then this term will become n. Then n minus n will become 0. So 0 factorial. So that is nothing but n factorial by, so t1 factorial, t2 factorial, t2 factorial, t3 factorial so on tk factorial into 1. That's it. So finally it will be simplified to n factorial by t1 factorial, t2 factorial, t3 factorial so on tk factorial. So from now onwards, you remember template number 5 is like this. You have an objects may not be repeated, and where a1 type of object is repeated t1 times and a2 type of object is repeated t2 times so on, ak type of object is repeated tk times, then the total number of arrangements of that n objects equal to n factorial by t1 factorial into t2 factorial into t3 factorial into so on tk factorial. That's it. Now we will see problems related to template number 5. So question number 1, how many 10 length binary sequences are possible with 7 zeros and 3 ones? Okay, the question is, you have to form a binary sequence with 10 positions, and that you should have 7 zeros and 3 ones. It's like an arrangement of these 10 objects, isn't it? 7 zeros and 3 ones. But if all are different, the answer is 10 factorial. But there are duplicates. 0 is repeated 7 times and 1 is repeated 3 times. Then how many arrangements possible for the 10 objects is, according to template number 5, it will be n factorial, that is 10 factorial by repetition number 1. 0 is repeated 7 times, then 7 factorial times into second repetition 3. So 3 factorial. So this is a direct formula, isn't it? In that way you can solve some questions very easily. Let's see the second question. This question needs an introduction. I'll introduce robo. So this robo want to travel from 0 0 to 3 3, but robo's capability is at any time either he will go 1 unit right, otherwise 1 unit up. So being at 0 0, he can go to 0 comma 1, otherwise he can go to 1 comma 0. He cannot come back, otherwise he cannot go down. So being here, let's say he cannot go back like this, and one more invalid step is going down. With these terms and conditions, How many different ways robo can move from 0, 0 to 3, 3? So finally, the summary is robo can move either 1 unit right, otherwise 1 unit up, but no going back, there is no going down. So whenever these kind of questions are given, so just give a thought like how to solve it. Always my suggestion is first think about some examples, like tell me one path first. You want to find out all possible paths. In this process, list out one path first. So one path is this one, you see, isn't it? So right, and followed by up. So I can write like this, right, up. So this is a hint. So I converted my path to a string. Whenever I convert a problem to strings or anything, then they can be solvable easily. That's my idea. Now one more path can be represented as, example, this one, you see, up, followed by right, u, r. By writing these solutions, I realized that by taking 3 rights, 3 ups, always I can reach this point. You try that. Example, let's write alternative rights and ups, RU. Yes, still it is giving. So what is my final conclusion? To come to this point, eventually robo should take 3 rights. That's compulsory. That right dimension should be taken completely. That means there are 3 rights, right? They should be completely taken, and 3 up should be taken, but in any way. Then finally problem is reduced to writing 6 positions. See, everywhere, every path is nothing but writing 6 positions, where on that 6 positions we have to write 3 rights and 3 ups. How many different ways you can write 3 rights and 3 ups in the line? It's again template number 5. If all are different, then we can arrange that objects in 6 factorial ways. Out of them, this object R is repeated 3 times, then divide by 3 factorial, and object U is repeated 3 times, then 3 factorial ways. So these 6 letters are arranged in 6 factorial by 3 factorial into 3 factorial, because this object is repeated 3 times, this object is repeated 3 times, isn't it? So same formula. So in that way you can solve questions related to template number 5 very easily.